Okay, this was number 3. So let me just show you what the picture looks like. That one, right? So for the first question, you can just ignore all the blue there. Are the same as go. What those two labels are. First up, they just wanted to prove that AB was equal to AC. Oh, and now I'm thinking there was an easier way to do B. But anyway, okay, that's fine. So they wanted you to prove that that line was equal to that line. Right? Now, guys, normally in a triangle, if they want you to prove that two sides are equal, you need to prove that the two angles opposite those sides are equal. Right? So what I did for that one, they did tell us that AC was parallel to BC. So did you guys notice that Z shape over there? Right? So because of alternate angles, A1 is equal to B1. Okay, so that's why I put the blue thingy there, and for B1. Now guys, if I want to prove that AB is equal to AC, I need to prove that those two angles are equal, right? So now I have that B1 is equal to A1. Is there a way to prove that C is also equal to A1? Tangent theorem, right? They told us that AC was a tangent. So A1, the angle between that tangent and that chord, is equal to angle C, which is obtained by the same chord in the alternate theorem. Okay, so that's what we did there. And then because they're both equal to A1, they have to be equal to each other. And then you can say AB is equal to AC because of sides opposite equal angles. I'll show you now. The actual working. There we go. So that's actually not a similarity question, right? That's like a proper circle geometry question. Okay, but is all unequal in geometry. So like I said, you have to. All right, B. What about A, guys? Yes. Is also yeah, so I use that for the next one. Okay, guys, now next up, they asked us to, now we didn't actually have anything, let me just check. We didn't know B2 yet, and we didn't have that B2 are equal. Now they're asking us to prove that AB bisects angle B, so this whole angle, right? So if AB bisects this angle, then B1 has to be equal to B2. So that's what we have to prove. Okay. So remember we had B3 new marking. Now this is what Talia was saying. You guys remember tangents from the same point outside the circle are equal to length. That was I think theorem 6, but we never proved it. So I think people came to forget it. So that's what I used there. I put that AC is equal to BC or PB. So this tangent from a common point, I'll finish the whole word now. And if these two lines are equal, then those two angles will be equal. Right, so then we have that B2 is also equal to A1, which was equal to B1. So there, that gives us, I call that B1 will be equal to B. Okay, so that's what I wrote for that. AP is equal to BP or PP. And that's the reason, guys, that's how it is written in the CAPS document. Tans from common point. So then I say therefore A1 is equal to B. So those are the two angles in the triangle there, which is now an isosceles triangle, right? Angles opposite equal sides. There's another way of doing it as well, because I didn't think of it earlier. I'll chat about that now. So therefore B1 is equal to B2, because again they're both equal to, here we said at the top, right? B1 is equal to A1. Here we now have that B2 is equal to A1, so therefore they must be equal. And so if you have a line going through an angle, and the two angles on either side of the line are equal, right? If you have a line going through an angle, and the two angles on either side of that line are equal, that means that the line cuts the whole angle in half. Which is what they are. Like this one. You will take it. Oh, sorry, I don't know what happened there. You'll definitely get a mark for that. And then you'll get a mark for this. One for B, one for B. 2 marks for this. But you don't need to put the grading in theorem that you've got. And also, this one, fine. That's A. And then I use that in B. So it depends on how complicated it is. If it has multiple steps within a mark each step. But if it's just one step, then it's normally 3 marks. And then you get a mark if you had to figure out the order at the bottom. Then you'll get a mark for that as well. Okay, guys, so for C, this similarity proof was not too bad. Yeah, sorry, but I was actually talking on this because I was thinking these two are very proven. Did anyone find a different method for B? Yes. Yeah? Yes, you could have. Yeah, correct. So, guys, let's look at this. We got that A1 was equal to C, and now we're saying that A1 is equal to B, right? But we need a B1 in W. So you can work around, okay. Yes, oh, I see. Okay, so if you have that, if you say that B is equal to C, because of tan port as well, and then you say that angle P is equal to B1 because of angle opposite equal sides, then those are equal. Yes, thank you. Perfect. Okay, let's look at C. Now in C, guys, they gave you the order again because in the question they said prove that triangle PAB is similar to triangle ABC. So that's the correct order. For this one, I didn't actually list my 3 angles because I thought it was not that bad to see. So, for example, here, now in terms of this, actually, there was something not tricky about this, but we just need to pay attention here. A1 and B2 are both equal to angle C. Right, so we notice that A1 is equal to C because of tan chord on that side, but then B2 is also equal to C. Right, also because of tan chord here. But we have to use the order that they've given us, guys. So when we're proving angle A in the one triangle, we have to prove that that's equal to angle B in the other one. Right, that is the correct order because they've given us a similarity statement. So you had to show that angle A here was equal to angle B there. Right, angle A in the first triangle, which is the outer one, is equal to angle B in the inner triangle here. So even though you could also say angle A1 is equal to C, because they've given the similarity center, right? We have to prove it in that order. So we have to say that A is equal to C. And then angle B in the second triangle has to be equal to angle B. Right, so that was just something, that was a bit pretty tricky last question. Okay. So guys, if you've already proven that 2 angles are equal, you don't have to write this reason again. I just wrote both. You can say from A or proven above or from above or something. Yeah. B2 is equal to C. Yes. So then you can just say from B or proven above. Yeah. We actually, guys, we had actually proven all of this stuff in A and B already. So, but if you're unsure, right, if you're like, I'm not sure if it's going to be okay if I just write from above, just write the actual reason. Okay, just to be safe. So A1 was equal to B1 because we proved it up there, we wrote it out already, but maybe if you haven't, then do we agree that A1 is equal to B1 because of that very change, right? Alternate angles there. Then B2 is equal to angle C because of tan chord, right? The angle between the tangent and the chord, B2, is equal to the angle subtended by that chord, which is C. And then the third angle, you can just say that they're going to be equal to each other. All right, so that was angle P equal to angle A2. And what's your reason for that third line always? Angle sum of All right, then you just rewrite the similarity statement, which is what they did give you anyway, the question. And your reason is angle and black. Now the next question, question D, was actually just a one-mark question. It seems a bit silly because it's saying prove that these two fractions are equal. Now guys, if you just do your frog faces, you're going to get those two fractions, right? So if we have our similarity statement, EA over AB, that's given out those fractions, so you can write it down, is equal to, what's the second fraction of equal? AB over BC. And that's actually just the second set of signs, right? AB over BC. Now guys, this will be a one-mark question. You'll literally just get a mark for your reading. Okay, because you don't have to do any like manipulation, you don't have to move sides across, you don't have to cross multiply. It's just using your similarity statement. Okay, we'll find that one. How was number 9? I didn't manage to finish number 9, so I'm going to do it with you guys now step by step. I'm just quickly checking here, and now I see that I drew my diagram like skewed to the other side. Okay, that's number 9, kind of. In the book, it's more skewed to that side, but anyway. Okay, they said that AB is a common tangent, right? So AB is a tangent to this circle and to that circle. That was kind of similar to the question that we did yesterday, right? If we go back to the example, that one, we also had two circles with a common tangent, right? But in this question, the two circles were on the same side, and the smaller one was inside the bigger. Okay, so it's quite similar to that one. So they are just saying we need to prove that, I'll write it down, prove QR is equal to PR QRT. So guys, this is like the second, well, the example that we did yesterday where they didn't give you the triangles that you're supposed to work in. Again, this one is quite straightforward. There are only 2 triangles, right? So we're going to have to work in, what is that, PQR and RT, right? I think that's clear enough. But if you weren't sure, let's do our check. If you look at the letters in this ratio, QRX, is that a triangle? QR and X, those are the 3 letters that we have here. QRS, no, hey? QRS is actually a straight line. And PRT, oops, sorry. PRT is also that straight line. Okay, so then we need to look across. So we can look maybe there and there at those letters. Yeah, I'm just reminding you of the method if you couldn't tell what the triangles were by looking at the picture. So you'll say QR and P, those are the 3 letters there. And QRT, PQR, that is a triangle. Correct. So that's going to be one triangle. And if you're looking at that grouping there, RS and RT, the 3 letters that I have there are RST, that is a triangle. Okay, so we are going to work in triangle PQR and triangle, my apologies, RST. If you struggle with this work, you would, or if you just want to maybe make it easier for yourself, you can list the 3 angles. So in PQR, we have P and Q and R5. And in RST, we have R2 and S and T. Now, I think many of you noticed straight away that R5 and R2 will be equal, right? So we remember those are the opposite angles. So there we go. There's one pair already. We can write that straight away as well. Now, guys, another thing about the order here, if you've written PQR first, you have to write PQR's angles first as well, right? So I'm going to write which R angle is in PQR, is it R5 or R5, hey, is in this one. So I have to write R5 first. don't know if I'll actually take that. Okay. And then the angle that's equal to the other triangle is R2. So you'll see when I'm listing my three angles, I always write the three angles in the first triangle first. Right? So PQR has those three angles, and RHC has those three angles. And then when I'm writing them down, I'm also going to write them down in the score. Okay. Is there another pair of angles that we can prove equal here? Obviously, the fact that they're given as a tangent, that means we're going to have to use it, right? Otherwise, they wouldn't have bothered. Yeah, yes. R1 and S, yes, because of transport here, correct? Honey? That's fine. Okay, so what did you say for R4? Yes. Okay, so let's do this for R4. R4 is equal to R1 and R1, which means yeah, good. Okay, guys, so you're working with tangent theorem here, right? That is a tangent, the angle between tangent AB and chord PR is R4. That angle is equal to the angle subtended by PR, which is Q. All right, so we find that R4 is equal to Q. Let's write that down. Just QR and chord theorem. All right. Then we have that R4 is going to be equal to R1 because of those three opposite angles. So R4 is equal to R1. Third angle is equal. But then R1 of the polar triangle is the angle between the tangent and this chord, which then subtends the angle at X. So R1 is going to be equal to R is T, again, tan chord theorem. Therefore, P to R is equal to R is. Now just keep checking what you're actually trying to prove, that the triangles are similar, right? So you need to prove that that angle is equal to that. Okay, so that's what your final line figure. And then what was the third pair of angles, which we could prove in exactly the same way, guys, but we don't have to, all right? If you wanted, if you proved it in the same way, you would then have four lines. Okay, which would be fine, but it would waste time. Because for your third set of angles, you can always just say this angle is equal to that angle, angle sum in triangle. Okay, so that would be QPR equal to RTX. Angle sum in triangle. Therefore, similarity statement now. Triangle PQR, like I said yesterday, for my first triangle, I always just write the letters in alphabetical order and then I match them up. So since we wrote P first, we need to write the angle that's equal to P first here. So P is this angle, right? The third one, and that is equal to angle T. So I need to write T first. Next, I wrote Q, which was the second angle here that I proved. Q was equal to angle X. All right, so X, and then obviously the third one will just be R, but R5 was equal to R2. Okay, So the R angle is equal to the R angle, so that is the correct order. Angle, angle. But we're not done yet, right? We still have to prove what they actually asked us to prove, which was that statement at the top. QR to RS is equal to PR to RT. Let's see if we can get that straight away just by looking at our front faces. So QR to RS, right? That's the same as SR. Okay, so that works. And then what was the second one? PR to RT, which is PR, which is the 10. So we can say straight away, therefore, QR to SR or RS if you want is equal to PR to TR or RT and then similar triangles. You can write it as two fractions at first if you want, but since they ask in ratio terms, you have to finish it by writing that. Any questions? Okay, I am going to give you more to practice today. I'm not going to do anything new. This section is just like circle geometry in general. The more you practice, the easier it's going to get. Okay. Tomorrow we have to do the last proof, which is the similarity proof, and one last type of question. But for now, I'm just going to ask you to do number. Maybe I'll just check before I just give you a question. I'll actually see that it's an okay question. Okay, exercise 11.7, page 306. Sorry, yeah. Okay, those two guys. 1 and 3. Number 1 has 4 questions and number 3 also has 4 questions. Sorry.